My name is Campbell, and I will be presenting some of our research with you this evening. By our research, I am meaning the collaborative work done by the Wildlife.ai Foundation and head office students, of whom I am one of. Okay, let's get into the facts. There are more than 100 species of wētā in New Zealand, 16 of which are endangered. One of these species is even called Jacinda. These rare wētās can be found on Taranaki and are named after our Prime Minister. There are several reasons why we are monitoring the population of wētā, and it's not just for their species' own survival. The kiwi bird will happily chomp down one of these little fellows without hesitation, making the wētā a part of its diet. Though there has to be some sad news. Because of wētā and were brought to New Zealand by early settlers, the wētā population is going down, declining. Wildlife.ai and a class from the head office have used devices called Wētā Watchers to monitor the population of them here in Taranaki, and tracking tunnels is a more old-fashioned technique. These also help to track the population of rats and other predators in the area. Of course, with work like this, there are always going to be challenges to get in the way of it. Shy wētā, storms, and curious possums can cause lots of damage to tracking tunnels and Wētā Watchers, not to mention the poor wētā hiding in their motels. And finally, our objectives. We want the monga to be a safe place for all wētā to live without the threat of a brutal extinction via the nasty vermin known as predators, not the movie ones. I will now introduce you to my scientific associate, Viv. She will tell you a bit more information on the devices we used. Thank you for listening to my segment, and have a good night.
Kia ora. My name is Vivian Bentham, but you can call me Viv. This evening I will be explaining about the technology we used on the project and the methods. Anyway, back to it. We did this project in Taranaki, specifically on our maunga. There is an area with a lot of A24 traps, which are traps for the introduced predators. On the 23rd of February, Dr. Victor Anton went up Mount Taranaki and laid the ink pad tracking tunnels for the next day. He put peanut butter on them so whatever animal walked over them could give us more of an understanding about what species there are in that particular area. The next day, the Year 7 and 8s from the head office went up the mountain where we were met by a team of Wildlife AI, the engineer who built the Wētā Watcher, the film crew, and Victor, who oversaw the whole project. In February and April, we spotted wētā footprints across 10 different tunnels. To my left, there are 2 tracking tunnels. One has wētā footprints, which you may not be able to see, and the other has rat footprints. As you can see, with the ink pads, we can't tell how many wētā or other animals there are. There could be 20 wētā, or just one, but we can't exactly identify them. With the Wētā Watchers, it's easier. When movement is detected under the device, the camera turns on and a video is made. The footage is then stored in a memory card and transferred to a computer where we can distinguish the animals. On the board, each animal is. Each square is 5 cm by 5 cm. We also used a method that included wētā motels. Wētā motels are little wooden boxes that insects such as the wētā can go in. Victor then goes and checks them to see if there are any insects in them. When we went up the mountain, we only found 1 spider and 1 wētā in 2 of them. The motels were only put down a couple of months previously, so the insects wouldn't have had time to get used to them. Even though only 2 animals were in there, it's still a good start. Thank you for listening to me. To my right, Mateo will talk about the results we found. Mateo, take it away.
Wētās are the main course of the forest and are heavily predated by many introduced species including birds, rats and possums. Victor has made an interactive map and diagram for our research. The map on the screen shows all the information from the tracking tunnels and Wētā Watchers. The map is based on the mountain and the green is the Taranaki National Park. You can see the shaded grey area, which we call the A24 block, which is protected from these predators. It shows us what the Wētā Watchers have recorded and puts it into a neat little map for us to use. The orange circles are currently showing the rat recordings, but they can also show the other recorded animals. The bigger the circle, the more sightings or recordings there were. The Wētā Watchers in the non-protected area have recorded that out of all the animals and insects that are recorded, 20% were rats, and in the protected area, the Wētā Watchers recorded 0% rats. Therefore, rats have been highly recorded outside and there's been little to none inside the A24 block. In the Wētā motels, we saw one Wētā in the A24 block and none outside it. Wētā have been recorded by Wētā Watchers significantly more inside than out. In the protected area, for every 14 tracking tunnels, there were 4 with Wētā prints. And in the protected area, for every 19 tracking tunnels, there were 11 with Wētā prints. The rat population in the controlled area is extremely different from the protected area. The Wētā are highly more populated inside the A24 block than out. The rats dropping to 0% in the more populated inside the block is proof that the A24 protection is working. If there is much more trapping on the mountain, we will see Wētā much more frequently. Thank you for listening to me talk, and I would like to invite Zach to speak.
Hi, I'm Zach, and I will talk about all the possibilities that there are for the Wētā Watcher. I think that the Wētā Watcher is an amazing piece of technology that allows scientists to view a variety of species and potentially find new ones within our wildlife community. With over 10,000 protected areas in New Zealand, covering nearly 1/3 of the country, the Wētā Watcher will be extremely effective to observe the biodiversity in our various parks by seeing improvement or decline in different species and areas. If the Wētā Watcher becomes popular with wildlife conservation groups, then the individuals at wildlife.ai could think about modifying it. For example, they could make the Wētā Watcher bigger, increasing the observed area and identifying larger species. Another thing that they could look about doing is putting a waterproof cover over it so it can't get wrecked in the rain. They could place bait or a scent on the pad to lure bugs or predators, increasing the chance of finding something new, or maybe even placing it on a tree to view tree-dwelling creatures opposed to the ground-dwelling ones. Of course, with these amazing additions onto the Wētā Watcher also come with consequences, such as the cost becoming bigger and you'd have to replace the bait once a week, but sometimes taking risks can definitely pay off. Another idea could be to look at programming the Wētā Watcher to be able to identify previously recorded insects, thereby speeding up the process of identification. This would also help because it could then group the insects and creatures and list how many of each animal has been seen over the days, weeks and months. This will help by seeing what animals are affected by the different environments. The Wētā Watcher is an amazing piece of technology that can help the Department of Conservation and countless other conservational groups see the amazing wildlife that surrounds us. It was a privilege to be invited to observe the Wētā Watcher first being used in the field. Seeing all the progress that is made on the Wētā Watcher is amazing. I believe that all the work that Victor has put into making this incredible device will definitely pay off. Going up the mountain was amazing, and seeing all the bugs and other animals that crawled under the camera, proving that it worked, was great. And I think that the Wētā Watcher will help hugely in the future of the protection of Wētā. To sum up what we have said today, please enjoy this short video about the Wētā Watcher and what we did up the mountain.
The Wētā Watcher project is a collaboration between scientists, community groups and local students from Taranaki, New Zealand. Working together, they designed and tested in the field a new way to monitor Wētā and other New Zealand wildlife. The Wētā Watcher is a device that monitors ground-dwelling wildlife species in their natural environment. As the animal crawls under the device, their movement is detected by a camera which records a short video. A machine learning algorithm in the device identifies the animal and sends a signal to the cloud. The signal contains information about the species, the date and the location. This information, captured by the Wētā Watcher, helps community groups, researchers and wildlife managers to know where the animals are and how to prevent species from becoming extinct.
So Wētā are really important from a biodiversity monitoring perspective because they're quite large and they're really easy to find, or relatively easy to find, as opposed to smaller critters that are out there. But they are also predated quite easily by lots of birds and rats. Possums love to eat them, that kind of thing. So if we can control those animals, then we basically have a really awesome data set to be able to show an area that is controlled versus an area that's not controlled.
The goal of the Wētā Watcher project is to test the devices on the field and to make sure that we can compare it with traditional monitoring tools.
Challenges we have with monitoring Wētā and other species like that is A lot of the methods are really old school. It's really difficult to tell how many are there, the size.
The Wētā Watcher is unique because it's the first camera that it has been designed for monitoring wildlife.
Because we're aiming to be in the field for weeks or months on end, and we don't have an internet connection permanently, it's necessary for us to use artificial intelligence on the device itself to identify the animal.
I think our students can be quite impacted by a project like this because they get to see things in action. They get to see potential avenues that they could walk in, especially like in the science areas.
Yeah, I really enjoyed it. I think it's better being out and doing actual physical learning.
In the classroom, it's just always just the same thing over and over again. I had a really good time.
We designed it as a user-friendly tool, and we want everyone to get on board and test it on their conservation projects.
For conservation on the ground, this technology would be a breakthrough. We feel like we could get a lot more done if time is saved by the machine learning.